Good morning, students. Am I audible? So, the second method we are going to discuss today is our Lesis theory. Okay. So, in our syllabus, we have two theory. One is your Kennedy's theory, and one is your Lesis theory to design irrigation canal or a channel, or you can say a drain of mobile boundary or erodible channel. Okay. So one you have Kennedy's theory and another method is your Lesis theory. So Kennedy's theory we have already discussed in the last class and it is an trial and error method. Your Kennedy's theory, okay? And in Lesis theory we are discussing today, okay? So you please write down the steps required in design by Lesis theory. So I think the steps are visible. You kindly write it down, okay? Because when you solve numericals, these steps is required, okay? So to perform Lesis theory, definitely we should know the discharge, okay? Okay, to perform Lesis theory, we should know the discharge. Definitely for this discharge, we are going to design that particular canal, okay? It is also called design discharge, okay? Then we need bed materials, or you can say sand size of the bed materials, okay? And always remember it should be in mm, okay? So we need discharge, then size of the bed material in mm, then side slope, okay? One vertical is to z horizontal. So if it is not given, then we can assume half horizontal or one horizontal, okay? So z is equal to, you can consider 0.5, z is equal to, you can consider 0.5 or 1, okay? Or 1, okay? So you have two options. If you don't know the side slope means we are going to design for trapezoidal channel, okay? So the side slope it is not given, so we are going to assume 0.5 or 1 if it is not given, okay? So the first step, from the known sediment size, that is the bed materials, and definitely always remember if the size of the bed materials it should be in okay? If it is not in then you have to convert into and then you are going to find out the silt factor by this equation, okay? F is equal to 1.76 root over d. D is nothing but your size of bed materials, or you can say size of sand, okay? But it should be in okay? So if in the numerical your bed size is given in centimeter, then you have to convert it first into and then you are going to substitute here, okay? So this equation is valid when you substitute this d value in okay? So this is our first step. Our first step is to find out the silt factor by using this expression, that is F is equal to 1.76 root over D. Okay. Then next step is to find out the velocity. Second step is to find out the velocity. Okay, and you write down this expression. Okay, that velocity you are going to find out using this expression, that is Vc is equal to qf square divided by 140 to the power 1 by 6. Okay, the second step is to find out the velocity by using this equation. Okay, so you write down this expression, qf square divided by 140 to the power 1 by 6 over. So here in the second step, you are going to find out the velocity using this equation. Vc is equal to qf square divided by 140 to the power 1 by 6. 1 divided by 6. So you are using this expression to find out the velocity in step number 2. Okay. So next step is to find out the area. So we all know area is nothing but discharge by velocity. So discharge is already known to you. Okay. And velocity you have calculated in step number 2. Okay. So in step number 3, you can find out the area. Okay. Then in step number 4, you are going to use the expression for area of a trapezoidal channel. Okay. Okay. Then in step number 5, because in step number 4, the area expression, area is known to you, but your width of the channel, or you can say bottom width of the channel, and y value is not known. Z value, if it is given, then it's okay. If it is not given, then we are going to assume 0.5 or 1. Okay. So that in this equation we have two unknowns. One is width of the channel and one is your y value. So that definitely with a single equation we cannot find out two unknowns. Okay, we need at least two equations to find out two unknowns. So that is why in the next step again we are going to consider the weighted perimeter equation of a trapezoidal channel. Okay, that is equal to twice y root over 1 plus z square plus b. Okay, what Lacey said, we can also find out the weighted perimeter by this equation. 4.75 weighted perimeter is equal to 4.75 root over q. Okay. So what we are going to do in step number 5, first we find out the weighted perimeter by using this expression, as q is known to us. Okay, q is known to us, so we can directly find out the weighted perimeter. And this weighted perimeter we are going to substitute in the expression of weighted perimeter of a trapezoidal channel. Okay, and then we have two equation and we have two unknown. One is width of the channel and one is depth of flow. Okay, then we are going to solve both the equations and we find out the two unknowns, that is your bottom width of the channel and depth of flow. Okay, so in the last step we are going to find out the bed slope using this equation. Okay, that is SB equal to F to the power 5 by 3, 3450 Q to the power 1 by 6. Okay, so you are kindly write down all the steps. Okay, because when you are going to solve numericals, we have to follow step by step. Okay, you have not solved any numericals related to Kennedy's theory. Okay, so first we solve numericals related to your Kennedy's theory. Okay, okay. So you write down the equation. Okay, okay. So your first numerical is related to your Kennedy's theory. Okay, so you write down this question. It is design a trapezoidal channel by Kennedy's theory with side slope one horizontal is to one vertical in alluvial soil to carry a discharge of 30 meter cube per second in a bed slope of 1 by 5000, and then this is nk, coefficient of cutter is given 0.0225, and CVR is nothing but your critical velocity ratio, or you can also say it is MR. Okay, so you kindly write down the question. Okay, over. So what is given? We have to design a trapezoidal channel by Kennedy's theory. Side slope is given one horizontal is to one vertical. That means Z is equal to 1. Okay, it's given. Z is equal to 1. Okay, then discharge is also given. How much? It's 30 meter cube per second. Okay, 30 meter cube per second. Bed slope is also given as b equal to 1 by 5000. Okay. Then nk is given. Coefficient of cutter, that is 0.0225. Okay. So these are the given thing, and mr, or you can say critical velocity ratio, is given 1. Okay. So if you remember the steps, our first step is to, we have to assume a depth of flow. Okay. So we have to assume the depth. We all know it's a trial and error method. So in the first step, we have to assume a depth of flow. Okay. So in first case, we have assumed 2 meter. Okay. I think we have already written the steps, so you can follow the step by step. Okay. The first step, we have to assume a depth. So in first case here, we have assumed 2 meter. Okay. In the next step, we need to find out the velocity. What is the equation for velocity is 0.55 multiplied by mr. This is nothing but your critical velocity ratio multiplied by y to the power 0.64. Okay. Okay. So 0.55 multiplied by mr. Mr is already given. That is your 1. Okay. And multiplied by y to the power 0.64. So 2 is y we have assumed is equal to 2. Okay. So 2 to the power 0.64. So calculate and see you are getting the same value or not. That is 0.857 meter per second. You are getting the same value. Okay. So the next step is to find out the area. As discharge is already given in the question, 30 meter cube per second, and then velocity we have calculated in the previous step. Okay. So we substitute here and we find out the area. Area is equal to 35 meters square. Okay. So in the first step we have assumed the depth of flow. Second step we have calculated velocity by using this equation, that is Vc equal to 0.55 multiplied by critical velocity ratio multiplied by y to the power 0.64. Okay. Then in the next step we are going to find out the area. So area is nothing but discharge divided by velocity. Okay. Okay. So in the next step, so definitely it's given we need to consider the channel shape is trapezoidal. Okay. Channel shape is trapezoidal and z value is given is equal to 1. Okay. Okay. So now we have to use area equation of a trapezoidal channel. Okay. Area equation of a trapezoidal channel. So area equation is nothing but b plus zy multiplied by y. Okay. So this is the area expression of a trapezoidal channel. Okay. So from this equation, area we have already calculated, that is 35 meters square. Okay. So width of the channel, this b is nothing but your bottom width of the channel. This is your b. Okay. This is nothing but your bottom of the channel. Okay. Plus z is value is given, that is 1. Okay. And y value we have already assumed as 2. Okay. So from this equation you can find out the width of the channel and see you are getting is 15.5 or not. Okay. 15.5 meter. bottom width of the channel, 15.5 meter. One plus z squared. Okay. This is the weighted perimeter equation of a trapezoidal channel. Okay. So weighted perimeter equation of a trapezoidal channel. Okay. So in this equation, z value is 1. It's given. Y value we have assumed as 2. Okay. And then width of the channel we have just now we have calculated, that is 15.5. Okay. So find out the weighted perimeter. Okay. And then you find out the hydraulic radius. This is nothing but area by weighted perimeter. Okay. So first you find out the weighted perimeter value. Okay. Then you find out the R value. Okay. Because area we have already calculated, that is 35 meters square. Area is already calculated, that is your 35 meters square divided by the weighted perimeter you calculate first by using this expression, and then substitute here and find out the R value. And see, you are getting the R value is 1.6543 meter or not. Okay. This is your R value. Okay. So first you find out the weighted perimeter. They have skipped one step. Okay. So it's always better you first find out the weighted perimeter, then you find out the hydraulic radius, and see you are getting the same value or not. To find out the velocity again. Okay, fine. Okay, okay, fine. Okay. So now we have to find out the velocity. Okay, you have to find out the velocity again. So I think you have that equation for velocity. V is equal to Okay, so this is the equation. 23 plus 0.00155 divided by your bed slope plus 1 by nk. Nk is nothing but your cutter's coefficient. Okay, divided by 1 plus again bracket 23 plus 0.00155 divided by base slope, and then whole multiplied by nk divided by root r. Okay, and the whole term is again multiplied by root over r into base slope. Okay, so this is the equation for finding velocity. Okay, so you use this equation and again you find out the velocity and see how much you got. It will be approximately 0.89, okay, meter per second. Okay, so here nk value is already given, bed slope is also given. Okay, r value we have already calculated. Okay, so you substitute here and find out the velocity and see you are getting the same value or not. Velocity equation, and you are getting the velocity as 0.89 meter per second. Okay, now we have to compare the velocity you have calculated in step number 2 and the velocity you have calculated just now. Okay, if both the velocity is same, then we can proceed. If both the velocity is not same, then we have to go back to our first step and we have to assume another value of y, or we have to go for second trial. So here in this case, if you see in the second step we got a velocity of 0.857, and in the velocity you have calculated just now we got 0.89. So these two are not same. Okay, so definitely your 0.857 is less than 0.89 meter per second. So what we are going to do, we are going for another trial, or you can say going for second trial, and assume the y value 2.2 meter. Okay, 2.2 meter. Okay, and then you continue till this step. Okay, so after solving this you go back to the your step 1 and you change your trial value to 2.2 and repeat those steps till your velocity here. Okay, okay, then again we need to find out the velocity by that equation. 0.55 multiplied by critical velocity ratio multiplied by y to the power 0.64. Okay, so now here the y value changes, it's 2.2. Okay, so you are getting the velocity is 0.911 meter per second. Okay, 0.911 meter per second. Okay, then we need to find out the area. Okay, so discharge is already known, so you can find out the area. Okay, once you find out the area by using the area equation of a trapezoidal channel, you can find out the width of the channel. Okay, okay, so once you calculate the width of the channel using the equation of a weighted perimeter, you find out the weighted perimeter, and after that you find out the r value, a by p. Okay, once you calculated the r value, again you use that equation, Cutter's equation for velocity, and you find out the velocity. Okay, and this velocity you are going to get using this equation. Okay, So these two are almost equal because this is corrected to two decimal point, 0.91 and 0.91. Okay, so you can say this is approximately same. Okay, so once this two velocity is same, then we can say that our assumed depth 2.2 is okay. Okay, so now our depth of the channel is 2.2 meter and width of the channel is 12.77 meter. Okay, whatever the width you are going to get with respect to 2.2 meter. Okay, then we have to provide free wood. Okay, so there are two situation. One is if it is less than 10 meter cube per second, discharge is less than 10 meter cube per second, then we are going to provide 0.65, and if it is greater than 10 meter cube per second, then we are going to provide greater than 0.75. Okay, these are the two conditions. What will be the free board? If the design discharge is less than 10 meter cube per second, then we are going to provide a free board of 0.65. Okay, if it is greater than 10 meter cube per second, then we are going to provide any value for free board which should be greater than 0.75. Okay, so that is why we have provided here 0.8 meter, and then this design depth will be 3 meter, and because of this 3 meter your design this width of the channel is also changing. Okay, so for that 3 meter depth you can find out the what will be the width of the channel by considering other terms as constant, okay, or as same. So this is the whole procedure how you can find out or how you are going to design a canal, or you can say for mobile boundary using Kennedy's theory. Okay, you see, we have already completed that canal design process for mobile boundary. Okay, so today we are going to discuss the process for designing canal for rigid boundary, or you can say non-erodible boundary. Okay? So designing of rigid boundary canal are also known as non-erodible channel. Okay, so in that particular case we have two methods. One is method of economic section, and another one is method of permissible velocity. Okay, we have two methods. One is method of economic section, Another one is methods of permissible velocity. You kindly write down for designing of rigid boundary, or you can say non-irritable channel. We have two methods. One is method of economic section, and another one is methods of permissible velocity. Okay, so that the methods of economic section is already we have studied. Okay, so you have also studied in fourth or third semester also in hydraulics paper, fluid mechanics and hydraulic machine. In that particular paper, you have already studied about economic section. Okay, so to design that particular channel, if we use the economic condition, then that method is called economic section. Okay, suppose for that particular question, in that particular question, design a rectangular channel in non-erodible, that means rigid boundary, in non-erodible boundary with discharge is given 20 meter cube per second. You kindly write down this numerical. Okay, 015. So now it's given as a rectangular channel. So if I want to use the method of economic section, then we have to use the economic condition of a rectangular section. Economic condition of a rectangular section. For example, B is equal to twice Y. Okay, this is the condition for your economic section of a rectangular section. Okay, so this is a economic condition for a rectangular section that you have already studied in your lower classes. Okay, I think it's in third or fourth semester. Okay, so we are going to use this expression in this numerical. Okay, to solve this numerical. So here what is given, non-erodible boundary channel is given, discharge is already given, that is your 20 meter cube per second. Okay, bed slope is also given, that is 1 by 3000. Okay, so this you can also write b by 2 is equal to y. Okay, it's up to you what you want to write. B is equal to twice y, or half of the width of the channel is equal to depth of flow. Okay, now you take discharge equal to area multiplied by velocity. Okay, area velocity, see Manning's equation is Manning's coefficient is given, so in place of velocity we are going to use Manning's equation. Okay, into r to the power 2 by 3 multiplied by sb to the power half. Okay, this is the Manning's equation. So this you can bring it in the left hand side. as with the power half. Okay, so if you bring it here, q multiplied by n divided by root over sb is equal to ar to the power 2 by 3. Okay, ar to the power 2 by 3. Okay, so from this expression you can find out the ar to the power 2 by 3. Find out how much you got, because this charge is known to you, that is 20 meter cube per second is given, and value is given, and slope is also given. So what we did, all the known values we bring it in the left hand side, okay, to find out the right hand side. That is, r area is not given, r is also not given, r to the power 2 by 3. Okay, so this two term is not known to us, so that is why we bring all the known parts in one side and we find out this value. See, you are getting the same value or not? 16.43. Width of the channel multiplied by depth of flow. Okay, okay. But we have that expression B is equal to twice Y from the economic channel condition. Okay, this is your economic condition for a rectangular channel. Okay, so if you apply this in place of B, you can write twice Y, so it will be twice Y square area. Okay, the area will be your twice Y square. Then for weighted perimeter of a rectangular channel is nothing but B plus twice, sorry, B plus twice Y. Okay. Again, in place of twice B, you can substitute twice Y plus twice Y. Okay. So area is your twice Y square, and weighted perimeter is nothing but your 2 plus 2, 4 Y. Okay. Okay. So we have used the economic condition of a rectangular channel, okay, to solve this numerical. What we did first we have used that area, discharge equation, that is nothing but area into velocity. In place of velocity we have used Manning's equation. Why? Because in the question Manning's n is given. Okay, so after that we bring all the known parts in one side and all the unknown parts in another side. Okay, so it will come as q multiplied by Manning's roughness coefficient divided by root over bed slope is equal to ar to the power 2 by 3. Okay, so we substitute all the known values and we find out the ar to the power 2 by 3. Okay, then we know area of a rectangular channel is nothing but width of the channel multiplied by depth of flow, as the economic condition of a rectangular channel is b is equal to twice y. So what we gonna do? We are substituting in place of b as twice y. Okay, so the area expression will become twice y square. Okay, and we all know parameter, weighted perimeter for rectangular channel is nothing but b plus twice y, and in place of b again we are going to substitute the economic condition. Okay, that is twice y. So if you add, you will get weighted perimeter for that particular rectangular channel is equal to 4y. Okay, now we need to find out the r value. R is nothing but a by b. Okay, area we have already got an expression of twice y square, and this is your 4y. Okay, so this is you will be y by 2. Okay, so your r is nothing but y by 2.
There is some technical issue. Kindly join again. Okay, I'm just ending this meeting here. Kindly join again with the same link.